Section 3.3 is on complex numbers. And not all quadratic equations have real number solutions. For instance, when we had x squared equals -1, we said there is no real solution, which is true. But because of that situation occurring often, engineers came up with a number to solve that equation. So if I would square root both sides, I would get x equals plus or minus the square root of a -1. This square root of a -1 is considered to be called I, imaginary, and I squared is always equivalent to -1. So with knowing that, here is an example that we can try. Square root of -5 should equal I square roots of 5. So if I have the square root of a -5, that is the same as the square root of a -1 times 5. Right here, we just learned that the square root of -1 is I. So I can take this out of the radical and put an I in front. So I have I square roots of 5. In this next example, we have I square roots of 5 squared. So if I take I square roots of 5 times I square roots of 5, I times I is I squared. Square root 5 times square root 5 is 5. Right here it says all I squareds are replaced with a -1. So this becomes -1 times 5, which is a -5. Since complex numbers are never real, it will never touch the x-axis. An example I have of that is bungee jumping. When you bungee jump, you never touch the ground. You just swing back and forth. Another would be a grandfather clock. The pendulum just swings back and forth, back and forth. Another would be a swing. These are all examples of imaginary numbers, complex numbers. So a complex number can be written as A plus BI, where A is your real number and BI is your imaginary number. Now, if we have A plus 0I, that simply means that we have only reals. The two kinds of reals we have are either rational or irrational. Rational numbers, again, are numbers written as fractions, like -1, 5/2, 3, where irrational are numbers that can't be written as fractions, like pi or square root 2. Then, if we have A plus BI, those are called imaginary numbers, like 2 plus 3i, 5 minus 5i. But if we would have zero plus BI, that is a pure imaginary, because all we have is the imaginary part, like -4i or 6i. So by having a complex number system, we can now solve any quadratic. So knowing that, let's solve 2x squared plus 26 equals -10. So I'm going to subtract 26. So I get 2x squared equals -36. Divide by 2, x squared equals negative 18. Square root. So I get x equals plus or minus. So square root 18 is a negative 1 times 9 times 2. The square root of the negative 1 is I. The square root of 9 is 3. Square root of 2 is still there. So I get I equals plus or minus 3I square root 2. So I still got two roots, which I should. They just both happen to be imaginary roots. Positive 3I square root 2 and negative 3I square root 2. Okay, let's solve this next one. Negative 1/2 times the quantity x plus 1 squared equals 5. I'm going to multiply both sides by a negative 2. X plus 1 squared equals negative 10. Going to square root. X plus 1 equals plus or minus, because I put that square root on. And this comes out to be a negative 1 times 10. So negative 1 square rooted is I square root 10. But that's what x plus 1 is. I want x. So I'm going to subtract 1. So whatever I do to this side, I'm going to do in front of this number. So I'm going to put my negative 1 in front there. And I get x equals a negative 1 plus or minus I square root 10, which is also two complex roots. It is a negative 1 plus I square root 10 or a negative 1 minus I square root 10. Since we can add, subtract, multiply, and divide any kind of number, we should be able to do that with our complex numbers. So my first complex number is negative 1 plus 2i. Then I'm adding 3 plus 3i. So when you do this, it's just like adding a two-digit number. You'll line up your place values. So I'm going to have my real part first, my imaginary part second. So my first number is negative 1 plus 2i. Then I'm adding 3 plus 3i. And negative 1 plus 3 is 2. 2i plus 3i is positive 5i. And there I have my sum of those two complex numbers. On this one, I'm subtracting and I'm adding. So in this first part, my real part is 0, plus my imaginary part is 2i. In this next part, I'm going to change it to add the opposite. So I'm going to have to distribute this negative through. So I get plus negative 3 minus I. And then when I put that positive through, I get plus 2 minus 3i. 0 plus negative 3 is negative 3, plus 2 is a negative 1. 2i minus I is positive I, minus 3i is minus 2i. This next one, I'm multiplying. So I'm going to take the negative I times 3 and the negative I times I. So that would be a negative 3i plus a negative I squared. All I squareds get replaced with a negative 1. So I have 3i, negative negative makes plus 1. But this is not in true complex number form, so I must rewrite it to 1 plus 3i to be in standard complex form. All right, then I have 2 plus 3i times negative 6 minus 2i. You're going to have to watch what is done in between your parentheses. Like here, it was adding. Here, it was subtracting and adding. Here, it's multiplying. So I'm going to FOIL this. So I'm going to take 2 times the negative 6, which is negative 12, and 2 times the negative 2i is negative 4i. Then I'm going to take 3i times negative 6i, negative 18i, and 3i times negative 2i, negative 6i squared. So that gives me a negative 12. I can combine these two. That gives me a negative 22i. This I squared gets replaced with a negative 1. So I have a negative 6 times negative 1 is positive 6. Negative 12 plus 6 is negative 6 minus 22i. Now, let's take a look at these two complex numbers multiplied together versus these two multiplied together. What's the difference besides just the numbers? Yes, this one has the same first term and second term. One with a plus, one with a minus, where these don't have any terms the same. When the first term and the second term are the same, just separated by a plus and a minus, we call those conjugates. So let's see what happens when you multiply conjugates. 1 times 1 would be 1. 1 times negative 2i would be negative 2i. Positive 2i times 1 would be positive 2i. Positive 2i times negative 2i would be negative 4i squared. So this gives us 1. Negative 2i plus 2i is 0. All I squareds get replaced with negative 1. Negative 4 times negative 1 is positive 4. So this gives me 5. So when I multiply two conjugates together, I get a real number. Now the reason that becomes important is because there is no such thing as dividing. So you can never have an imaginary in your denominator because we cannot divide by square roots. So this is the square root of a negative 1. So to get rid of that denominator, you multiply by its conjugate. So I'm just going to rewrite this number. 3 plus 11i over negative 1 minus 2i. So this is where I can't have the square root in the denominator. So I must multiply by the denominator's conjugate, which would be negative 1 plus 2i. Same first term, same last term. One's a plus, one's a minus in the middle. So what I do to the denominator, I must also do to the numerator. So I'm also going to multiply the numerator by negative 1 plus 2i. So when I do this numerator, I get 3 times negative 1 is negative 3, plus 6i minus 11i plus 22i squared over, I'm going to just keep solving there. I squareds get replaced with a negative 1. So I have negative 3 minus 5i minus 22, which gives me negative 25 minus 5i. Now I'm going to do the denominator. Negative 1 times negative 1 is positive 1. Negative 1 times negative 2i is negative 2i. Negative 2i times negative 1 is positive 2i. Negative 2i times positive 2i is negative 4i squared. Again, this cancels, so I get 1. I squareds get replaced with a negative 1. So I have 1 plus 4, which is 5. So I have this negative 25 minus 5i all over 5, which I can split into my real part. Negative 25 over 5 minus 5i over 5, which reduces to a negative 5 minus I.